We will now show the second property, or property A2. This is the associative property. Okay, so we will show that for all u, v, w in the set V, we have to show that this equality holds here. Alright, so I would like to emphasize first yung kanina, no? Okay, take note that our symbol here is this operation, no? So vector addition. So okay, so it must be this symbol. Okay, right, so dito must be this symbol also. Right. Okay, so similarly dito, okay, it must be that symbol. And this one. Okay. So second property, we are going to show this one. So to do that, let us pick these elements in Rn. Okay, then we will show that from left to right. Okay, so from here, that is vector u plus v plus w. Okay, so this is equal to vector u plus, this is v plus w. So naka-parenthesis na because of this one. Okay, so, and that is equal to, okay, so this is equal to, okay, this is vector u, u1, u2, un plus, okay, so this one here is the matrix v1 plus w1, v2 plus w2 up to vn plus wn. Okay, so this is now equal to, alright, so this one plus this, so that is just, okay, so u1 plus this quantity, that is v1 plus w1, right, similar with u2, okay, v2 plus w2 up to un plus, okay, let me move that, un plus, okay, this is vn plus wn. Alright, so again, so the entries are ito, these are elements of the set of real numbers, and we note that the set, no, the set of real numbers is associative. So because it is associative, we can write this one as, okay, we can write this one as u1 plus v1. Okay, itong naka-highlight na, plus w1, similar to the other components. Okay, so u2 plus v2 plus w2 up to un plus vn plus wn. Okay. Take note that our goal is to show this one. Okay, so we are near to that. Again, so we will split natin ito. So this one, so that is u1 plus v1, u2 plus v2 up to un plus vn. Okay, plus you have w1 W2 up to W sub n. Okay, and that is just equal to, right, so that is just equal to this one can be written as the quantity u1 u2 up to un plus v1 v2 up to v7. Okay, and this is plus this matrix w1 w2 up to w sub n, and we know now this is just equal to, this one is the vector u plus this is the vector v, okay, plus this one is the vector w, and I think we have shown already, no? So okay, so that is the vector w, and again our notation for vector addition is this one. Okay, therefore we have shown this one. It's property A2. Okay, so property A2 is now checked. Property A3, there is an element 0 such that u plus 0 is equal to u for all u in V. Again, this is existence of element. So, kailangan makahanap tayo ng element, no? So, there is an element. So, that is existence. So, kailangan ka makahanap ng 0 doon sa vector space. Such that kapag i-add mo sa any vector, ang result niya is itself. Okay, so that is property A3. So we will proceed to property 3. So kailangan natin makahanap. So let us pick an element. Let V, for example, a vector in Rn. So this is a vector. This is an element. This is an element of Rn. Then, okay, so we know that this vector here, okay, v1, v2 up to vn, which we can just rewrite this one as v1 plus 0, v2 plus 0, up to vn plus 0. And we can also rewrite this as v1, v2 to vn plus this matrix 0, 0 up to 0. And there are n zeros here. Okay, so we will now let this one be equal to our 0 vector. So, ito na yung nakita natin, no? So, set the 0 vector be equal to this one, to 0. And this is an element of Rn. That is an element of Rn because these 0 are in real numbers. Again, emphasize ko lang, no? This property here is true because this 0 here, this 0 is the usual 0 in the set of real numbers. This is called additive identity. All right. This is the additive identity in the set of real numbers. So that is true for R. Alright, so may nakita na tayo na 0 sa R. Okay, so what is the property of that 0 in R? Okay, so in the left side, this one, we can write this one as the vector v. That is the vector v. And this is equal to this vector v plus 0. So this is just equal to the vector v plus vector addition plus the 0 vector. Okay, so therefore, there exists a 0, particularly this vector in Rn, such that, okay, vector v plus the 0 vector is equal to v for any vector v in the set of Rn, right? For the fourth property, we show that for every u in v, there exists the negative of u, the negative this one in v, such that, okay, so u plus negative of u is equal to the 0 vector. Okay, so this is for all, right? For all u, there exists. So, kailangan nating makakita ng negative ng vector na ipipick natin sa v. So we start with an arbitrary vector or arbitrary element of Rn. Okay, because u is in Rn, the entries of this matrix are element of real numbers. Okay, and because they are real numbers, meron yan siyang mga additive inverse. So each u, alright, each u here has an additive inverse, meaning there exists a ui in the set of real numbers such that ui plus the negative of that is equal to 0 for all of ui, where I ranges from 1 to n. This means that this particular matrix is in Rn, and we verify if it's true. Alright, so try natin i-add doon sa ating u kasi may nakita na tayo na negative niya. Okay, this is our vector u plus, this is our vector, this particular vector, we will name that later on. This is u1, u2 up to un, and this is equal to u1 plus negative u1, alright, u2 plus negative u2 up to un plus negative un. This is equal to, right, based on this one, this is equal to 0. Okay, so all entries here are 0. Okay, this is 0, 0 up to 0. Okay, so in effect, this particular matrix here is the negative of this one. And so if we set this particular matrix to be the negative of u, so this equation becomes this equation. So yan man ang ating gustong makuha. So property number 4.